Hello, my name is Recordon, and during these past 4 months, I completed my internship as a software engineer intern at Inventario, a company that develops hardware and software solutions for inventory management in agricultural warehouses. My main responsibility was to design and build a new mobile application that extends the company's existing inventory system. Today, I will explain the most technical challenging part of that work. Inventario currently operates within industrial touchscreens devices installed in warehouses environments. These devices can scan products, weigh them, and communicate with a backend deployed on AWS. My internship project was to build a mobile version of this system, allowing users to perform all operations directly from their smartphones. This would reduce onboarding costs, simplify maintenance, and improve the flexibility of the workflow. The most challenging engineering problem I faced was designing the data processing logic for handling multiple simultaneous orders on the mobile app. At first glance, scanning products for a single order seems simple, but in real agricultural workflows, operators commonly work with several orders at once, with overlapping products and variable quantities. The mobile app needed to support this while keeping the logic consistent, error-tolerant, and aligned with the backend. My initial approach followed the structure already used in the fixed hardware system. Each order contained its own list of required products and a separate list of scanned items. This design worked for single order processing, but it quickly became unmanageable when multiple orders were selected. With this model, the frontend had to decide how to divide scanned items across orders, detect duplicates, merge equivalent products, and keep internal states synchronized. Each new requirement introduced complex edge cases. For example, the same product belonging to two different orders had to be displayed as a single combined entry in the UI, while still preserving order-specific data internally. This created fragile logic and made the workflow difficult to maintain. To solve this, I redesigned the architecture of the mobile data layer. Instead of loading individual orders and trying to coordinate them, the frontend now generates a single structure called the combined order. The combined order aggregates three key components: a list of all the order IDs selected by the user, a merged list of required products across all orders, a unified list of scanned items. This new structure removes the need for the frontend to calculate product distributions or quantity splitting. Anytime, whether it belongs to an order or is an alternative product, is simply added to the combined list. The backend later performs the necessary validation and distribution across orders. This redesign significantly improved the maintainability of the code, reduced internal complexity, and aligned the app with real agricultural workflows, where exceptions and alternative items are common. Implementing this design required restructuring state management using React Query and Substance. One key improvement was isolating the frontend's responsibility. Instead of preparing order-specific payloads, the app now sends a minimal and consistent data structure to the backend containing only scanned items and the order IDs involved. This simplification eliminated the need for complex synchronization logic and allowed the backend, where business rules already exist, to handle product allocation. Another important aspect was designing the state's transitions to be resilient. The app had to support offline queues, optimistic updates, and clear rollback behavior in case of API failure. These considerations ensured that the new workflow remained reliable even in remote agricultural environments where connectivity is unstable. This activity was the most challenging one in my internship because it combined requirements engineering, data modeling, state management, backend and frontend alignment, and real-world workflows constraints. I learned the importance of fully understanding user process before coding, validating assumptions early with domain experts, and designing data structures that provide long-term scalability over short-term patching. In conclusion, the redesign of the multi-order processing workflow not only strengthened the mobile app, but also contributed to the scalability of Inventario's entire system. This experience gave me significant professional growth and hands-on experience in real software engineering challenges. Thank you for watching.